We are live. Hi everyone, welcome back to Code Era. Today in this video, we'll be discussing the Leetcode daily challenge for today, that is 18th of January 2022. The name of the problem is Can Place Flowers, and in this problem, you have to apply a greedy approach basically, and this is an easy problem. This problem previously has been asked in companies like LinkedIn and Google. So we'll be starting with this problem, but first of all, consider giving me a quick +1 in the chat if my voice is audible to everyone and my screen is also visible, and then we'll start with this question once everyone else joins in. And comment down below that if you have solved this problem for today, that is Leetcode daily challenge for today. So comment down a yes in the chat, and if you haven't done that, so comment down a no. And I hope that after this end of this live stream, if you haven't solved this, so you will be solving it, right? So I'm just looking into the chat, so just quickly let me know. Okay, right. So in this problem basically, this problem is a greedy one and it's very easy. As I told you, it has been asked in companies like Google and Amazon, so I'll just be waiting for 1 or 2 minutes more for everyone else to join, and then we'll surely begin with the session. Okay, so just let me know how many of you have solved this particular problem. Okay, right. So the problem name is Can Place Flowers. It's a easy level problem. As I told you, has been asked frequently in LinkedIn and Google. So in this problem, what you have to do basically, you have a long flower bed. So you have been given a flower bed in which some of the plots are planted. Okay, some of the plots are planted there and some are not, right? However, flowers cannot be planted in adjacent pots. So a flower can be planted at a position only if it does not have any adjacent flower towards its left and towards its right. Okay, so you have been given an integer array named as flower bed, okay, which contains 0 if the current flower bed is not if the current at the current ith index the flower is not there, so it contains 0. If there is a flower, then it contains 1. And what you have to do is you have to return true if you can place n flowers, n new flowers, that if you can plant n new flowers in the flower bed without violating the conditions that no two adjacent flowers should be adjacent. Okay, so is the problem statement clear to everyone? Please consider giving me a quick +1 in the chat if the problem statement is clear to everyone. Is the problem statement clear to everyone? Give me a quick +1 in the chat if the problem statement is clear, right? So for this particular problem, if I'll tell you, what you basically have to do is you'll be given an array. Let's suppose that you have been given an array like this. Okay, let's suppose that you have been given an array something like this, 0, 0 and 0. Okay, so what you could do is you can place maybe one person here, you can place one flower here, and this array would look like 1 0 0. So in this the adjacent flowers, there are no adjacent flowers, so that is why you can place it, right? Let's take some of the examples. So let's say if the flower bed is 1 0 0 0 and 1, okay, and you have to place one flower in it. So if the flower bed is 1 0 0 0 and 1, in that case you have to place n is equal to 1, so you have to place one flower. So can someone let me know in the chat, like, where will I place the flower? Where will I place the flower? At which index should I place the flower? Anyone would like to tell me in the chat? So if I look at this particular position, so this particular position is occupied, so I'll not place a flower here, right? If I look at this particular position, so will I place a flower here? No. Why? I'll not place a flower at this particular position. The reason for that being that if I place a flower here, so towards its adjacent right there is no flower, but towards its adjacent left, that is, you can see in the left there is one flower, that is why it is index 1, right? The element is 1, so that is why I cannot place it here. Okay, then I move to this particular index, right? So I can see that for this particular index there is no element present. No, there is a 0 towards the left and there is a 0 towards the right, so indicating that in the both the adjacent sides, that is towards the left and towards the right, there is no flower placed, so I can safely place a flower here, right? So what I'll do, I'll place a flower at this particular position, so this becomes 1 0 1 0 and 1, right? So I can see that I had to place one flower and I have placed it. What if n was 2? What if n was 2? Can I place two flowers in this particular array that has been given to me? No, I cannot. Why? Because the next position that I could place is this. But can I place a flower here? No, I cannot, because the adjacent elements are both the adjacent left and right are having a flower. So this will violate the condition that a particular flower should not be adjacent to two other flowers, right? So can I place it here? No, there is already a flower placed, so I cannot. So that is why the maximum number of flowers that I could place in this particular thing was only one, right? Now let's have a look at this particular test case. Just quickly comment down below how many flowers can we put in this. How many flowers? What is the number of flowers that I can put in this array? Just let me know a little quick in the chat. What do you think? How many flowers can I insert in this particular flower bed? Anyone would like to tell me? Anyone would like to tell me how many flowers can I put? So basically, if you will notice, so I have what? I have 1, I have 0, I have 0, I have 1. Okay. So I start from this particular index. I see that it is already occupied, so no worries. Then I come to this index. I see that the left is occupied, right? The left is occupied, so that is why I won't be able to place it. Both the adjacent should be empty, right? Then I come to this particular index. Its left is empty, right? The left element is the left flower is not there, but towards the right you have a flower, so you cannot place it. And then you come to this particular index. So at this particular index it is already 1, so that is why you will not place a flower here as well. So totally you cannot place any flower, so that is why if the value of n was greater or equal to 1, in that case the answer would be always false, right? Because you cannot place any flower. What if this is the situation? Let me know. If this is the situation, how many flowers can I place in this particular scene? So just comment down a little quick that how many flowers can we place in this particular situation. How many flowers do you think that we can place in this particular situation? Just comment down a little quick, right? So how many flowers? So Ron is saying 1. Okay, so how I can say that? So I have this particular position. I can see that towards its left there is no position, because this is the first index. So towards its left there is no adjacent left, so that is why no worries. No, I'll have no problem. And towards its right, this position is empty, right? So I can place a flower here. So I can do 1, 0, 1. And in this way I can place one flower. Similarly, let's look at another example, right? Let's say that if it was 0, 1, 0, 0, right? If it was something like this, can I place, if I had to place a flower, can I place a flower at this particular position? No. Can I place a flower at this particular position? No, because towards its adjacent left there is a flower, right? Can I place a flower at this particular position? Yes, I can place a flower at this particular index. Why? Because towards its right there is no other element, because this is the last index. This is the n-1th index, right? And towards its left there is no flower placed, right? So I can place a flower at this particular position. So this will become 1, 0 and 1. Okay, something like this. Okay, is this part clear to everyone? I hope that it is clear, right? So you could place a flower like this and this would work. Now let's have a look at the test cases now, right? So what if this was the test case, that let's say it was 1, 0, 0, 0, 1, right? So in this particular test case, we know that we can only place a flower at this particular position. So this would become 1, 0, 1, 0, 1, right? Maximum of 1 flower can be placed and the n value is given to be 2. So I will write a false for this. So how can I find whether I can place n number of flowers or not, right? The question is, can I find, how can I find that how many number of flowers I can place? Can I place n flowers or not? So what I would be doing is, whatever the arrays has been given to me, okay, whatever the array has been given to me, what I can do for this particular array is count the maximum number of flowers. Okay, for this particular array, count the maximum number of flowers. Okay, count the number of maximum number of flowers that can be placed, that can be planted, basically that can be planted. Okay, you just count what is the total number of flowers that you can plot. Okay, so if that count is greater equal to n, if the number of flowers that you can plant in the given array, if the total number of new plants that you can plant, if the total count is greater equal to n, in that case you simply return a true. Okay, if the total number of flowers, new flowers that you can plant in this particular given array, if it is greater equal to n, so if the count is greater equal to n, so you return true, else you return false, right? So is this much part clear to everyone? Please consider giving a quick +1 in the chat if this part is clear, right? Is this part clear to everybody? Okay, let me know a little quick if this part is clear or not. I hope that this part is clear, right? So how the thing is that how do you build the code for this particular thing, right? How do you build a code? How would you build a code for this one, right? So what you could observe is that there are basically three situations when I can put a flower, right? If I am at the starting, right? If let's say I have some indexes like this or this, okay, so considering a indexing based approach, so this is index number 0, this is index number 1, this is index number 2 and 3, right? So if my I is equal to 0, and right, if my the ith index is if the current index is 0, right? If my current index is 0 that I am at, if it is 0 and it is empty, okay, if the this is empty, so if what happens is a of I is 0, right? A of I is 0 and I am at the first index, right? So in that particular situation I need to check that what is the situation towards the right. So if my a of I plus 1 is also equal to 0, in that case I can say that I can place it, right? I will say that yes, I can place a flower. So I'll mark my flower bed of at the flower bed. I'll say that, or let's say at a of I, right? A of I will say that let's mark it as 1. Okay, and let's do the counting. So I'll do a count plus plus, right? Like this. Next up, what I could do is another thing that you needed to observe, as I told you about this particular test case, right? For this particular test case, I can see that I can place something at the end. So this could be a situation that if suppose n is equal to n minus 1, I is equal to n minus 1. So if I'm at the last index, then I need to check that if my a of I minus 1, that is the left element, that is this element, if this element is equal to 0, then also I can place. So I'll mark my counter as one more. I'll increase my counter by one more, right? The reason is that I'll increase the counter by one more because I can place a flower, and then I'll say a of I is equal to 1, right? At the current position, since I'm placing a flower, so that is why I'm doing it, right? So this is how I can do it. Now there is another situation that I can place it, right? So how can I place it? If my a of I is equal to 0, right, and my left and right both are existing, right? If a of I is equal to 0 and my left and right both are existing, if I've checked for I minus 1 and I plus 1, so like if I've checked for the leftmost, that is the first index and the last index, then all the other indexes would be middle, right? So if my I minus 1 is equal to 0, a of I minus 1 is equal to 0, and a of I plus 1 is also equal to 0, in that particular situation as well, I'll simply count. So I'll increase my count because at that particular situation also I can put the flower at the ith position, and I'll mark a of I is equal to 1, right? So that is saying that it is a flower has got planted, right? So this is some way that I can do it. But can I write the code in a much simpler manner? Because you will observe that here you have to take care of some particular cases, right? A lot of cases. So what I could do instead is I can try to simplify the code a little bit more, right? I can try and simplify our code a little bit more. So what I would be doing is I can simply say that let's mark my count as nothing but 0, right? What I would be doing is, for my I starts from 0, I is lesser than n, that is the not n, I is lesser than flower bed dot size, okay, flower bed dot size. So basically the size of the flower bed, the array that has been given to me, then I do an I plus plus simply, and what I will do is if I'll check if my current ith element is equal to 0, right? If the ith element is 0, okay, if the ith element you can say flower bed is 0, so this can be said as a dot size or something like that, whatever the array has been given to me, right? So what I will do is there are some situations that I need to analyze. Either my I should be equal to 0, right? When will I put at a particular position? Let's say this is the situation, so either this should be like this, okay, for this particular element, if I am at the first index, right, considering for the left, for this particular index, if my I is 0, so I do not have to consider for the left, right? So I can place a flower if my I is equal to 0, and for this particular position I need to check for the right, so I'll check for it. Or otherwise, if the left is existing, so I'll say or I minus 1 is equal to 0, right? So if suppose that there was a situation like this, let's say it was a situation like this, okay, it was a situation like this. So if I was at this particular situation, right, if I was at I is equal to, let's say, 2, so in that case its left is existing, right? So that is why I'll check for a of I minus 1. So I need to check for the left adjacent, right? So this condition, this particular thing is checking for the left, okay, left adjacent. I'm checking in this for the left adjacent. If my I is 0, then I can place it, right? That means if I am at the very first index, then my left is empty, so I'll say okay, don't worry, I'll check for the right as well. Or if my left is existing, that is if I am somewhere in the middle, so my left would be existing. So if my a of I minus 1 is 0, then I would place it, right? And now I will write and so the left position, in the left position, either I can have two situations and one of them must satisfy. Either I'm at the very first index, then my left does not matter because left will not be existing, or if my left is existing, then I'll check whether my left, that is a of I minus 1, is 0 or not, right? Similarly, what I would do is, if my I is equal to n minus 1, right? If I'm at the end, let's suppose that this was a situation. So here, somewhere here, if I'm at the end, if my I is equal to n minus 1, that is if I'm at the end, not I, n minus 1, basically a dot size, right? A dot size means the size of the array that has been given to you, right? So if I'm at the last index, so what I could do, I can place it because I don't need to worry for its right adjacent because there is no right adjacent. Or I can say that if it is existing, so let's say for this particular case, so if I am at this case, right? So for this I is equal to 2, its right is existing, right? So if its right is existing, so a of I plus 1 should be equal to 0, right? In that particular case also I can say, so this is the situation that I am checking, that I will check for the right. This is the situation that I will check for the right adjacent element, right adjacent. So these are the two situations that I'll check. For the left, either my I should be 0, or if my left is existing, if my left element is existing, I am somewhere in the middle. So that is why a of I minus 1 should be equal to 0, right? This is what I would do. I hope that this much part is clear, right? If this much part is clear, you can consider giving a quick +1 in the chat, right? Now, the thing is that you check for the right. So if you are at the end, if you're at the last index, right, and it is 0, if you are at the last index and it is 0, so you'll check for the right. So they basically, if you are at the last index, so there is no right, so you will not have to worry about it. And if you are somewhere in the middle, so you will check that a of I plus 1 is equal to 0. So basically in this particular part, we are checking for the left. If either of the condition is true, that means the left is empty and you can place it. If you are at the starting, so the left does not matter for you. And if you are somewhere in the middle, so left should be empty. Similarly, if you are at the end, so that is, if you are at the end, so that is why its left does not matter to you, like its right does not matter because you are at the last element, so there is no adjacent right. So you'll say okay, I can the right adjacent gives me a clearance, right? If you are somewhere in the middle, so you will check that whether the right adjacent is allowing you, right? If it is allowing me, then in that case what should happen, a of I plus 1 should be equal to 0. So at that particular situation, what I would do, I would simply say that let's mark my a of I as 1, right? And I can say that let's increment the counter because I will have one more counter. After that, let's close this, and in the end I'll simply return what n is count. I'll simply return count is greater or equal to n, right? So if my count is greater or equal to n, right, if my count is greater or equal to n, then it will return true, otherwise it will return false. Also, you can do one more thing, that the moment if you can do that, if your counter is greater than n, right, if your counter is greater or equal to n, in that case also you can return a true, that will also work, but in the end you need to return false. So in the worst case, the time complexity, talking about the time complexity for this particular code, right, so since we are traversing throughout the array, so it will be somewhere close to order of you can say size of flower bed, so order of a dot size, the size of the array that has been given to you of zeros and ones, right? And apart from this space complexity, since we are not using any extra data structure, any extra array or something like that, so that is why the space is order of 1, right? Another thing that you could have done is, if array mutation was allowed, right? If array was allowed to be changed, right? So what you could have done is, let's suppose that this particular array was given to you. So what you could have done is that since you want to check for the left and right, so you could have placed some 1 0 here at the starting and 1 0 here at the end. So you could have inserted 1 0 at the starting and 1 0 at the end, and then you could have iterated from I starts from 1 and I is lesser than a dot size, something like this, okay, a dot size minus 1, and you could have done an I plus plus, and you could have checked that if a of I is 0 and a of I minus 1 is also 0 and a of I plus 1 is also 0. So basically if a of I is equal to 0 and a of I plus 1 is equal to 0 and a of I plus 2 is equal, a of I minus 1 is equal to 0. In that case also you could have made the counter to be increased and you could have updated a of I is equal to 1. But in this case you are manipulating the array. So if the interviewer asks you not to manipulate the array, so in this case you have to do it the way that I have told you. Let me show you the code part for this particular problem, like how I've done the code for this, right? So I'll have a function in which I'll be passed the flower bed as a vector, and then I'll be having n, that is the number of flowers that I want to place, right? So for this particular, I can see a lot of people have joined. So please consider giving me a quick +1 in the chat if my voice is audible to everyone. And up till now, the question must be clear to everyone, right? All of you, please like the video and please consider giving a quick +1 in the chat. Is this particular problem clear to all of you? Is it? Is it? Just let me know in the chat a little quick. Hi, Aryan. Okay, is this problem clear to you? If someone new has joined, so don't worry, after the stream is over you can go through the video at 1.5x speed and you can do this. So one more thing, once you have submitted this particular problem, like this is the problem of the day for today on Leetcode, that is Leetcode daily challenge for 18th of January. Once you have solved this problem, so after the live stream is over, come back to this video and write that I have submitted the Leetcode daily challenge for today. Like I have completed the Leetcode daily challenge for today. Okay, so in this way what would happen, you would be compelled to solve this particular problem on Leetcode today, right? So this is what I'm expecting from you. Hi Anita, hi Shaheen, hi all of you, right? So try to do this. Okay, this is a very easy problem. So I have explained since last 22 minutes I was explaining this problem. So if someone new has joined, so you can just search जाते हुए बाई search class की timing बताकर जाना. Today we will not be having a binary search class. Most probably I will have a binary search class tomorrow, so it would be 7 p.m. tomorrow if I have a class. So it would be 7 p.m. tomorrow, and I'll try to solve 2 problems tomorrow, okay, on binary search code forces, right? So what I would be doing is I'll simply check if my flower of I is 0. So if my ith element is 0, so there are 2 conditions that I need to check in the left. Either if I am at the first element, so in that case there is no left, so I'll say okay, right? I need to this condition will check for the left and this condition will check for the right. This condition will check for the left adjacent. So if I am at the first element, in that case I'll give myself a clearance. Or if I am somewhere in the middle, so my I minus 1th element should be 0, right? So this is the condition that I am checking for the left. Either of them will be true, right? And if it is true, then that's fine. And if I am checking for the right, so if I am the last element of the given array, if I'm the last element, in that case it does not matter, because in that case there is no right adjacent to me, right? So in that case this thing will pass, so it will give me 1 because I'm using or otherwise if I'm somewhere in the middle, so I plus 1 nth element should be equal to 0, right? So this is what I'll check. In that case I'll mark my flower of I is equal to 1 and I'll do a count plus, okay? And in the end, since in the worst case it will be order of n only, so that is why I'll be returning if the total maximum number of ones that I can place, if it is greater or equal to n. So in that case this will return a true, otherwise this will return a false, right? This particular condition. So if someone has seen the mastering greedy series, let me tell you about it. So if someone has followed my mastering code forces greedy series, right? So he or she would be able to do this question very easy, right? There are 7 videos in the mastering code forces greedy series. So if someone has watched a few of them, so in that case he or she would be able to do this. So consider giving me a quick +1 in the chat if this problem is clear to all of you. Also, if you solve, come back to this video after submitting on Leetcode, and comment that I solved the daily challenge for today, okay? This will help you get compelled, okay? This will help you be in a habit, right? Let's make it a habit to solve the Leetcode daily challenge every day, okay? If everyone agrees, please consider giving me a quick +1 in the chat, right? Okay, everyone will do this, right? Right after this stream, go to the Leetcode, try to write your own code, or you can use my code as well. Like if you have understood my code completely, then you can submit it directly, or